Welcome to Brain Vision.
Hello everyone, this is the solution to problem 28 of chapter 24 of college physics. Here we're given some details about different ultraviolet bands of the electromagnetic spectrum, and we're asked to find what the range of their wavelengths correspond to in terms of frequencies. So first we're given that UVA light or UVA electromagnetic waves have a maximum wavelength of 400 nanometers and a minimum wavelength of 320 nanometers. And we're asked to find what the frequencies of UVA light can be. So what is the range for these frequency values? Well, the maximum wavelength is going to correspond to the minimum frequency. So similarly, the minimum wavelength is going to correspond to the maximum frequency. So given that, we can write the speed of light as lambda times f, because it's an electromagnetic wave. We can rearrange for the frequency value, and so f UVA maximum is going to be c divided by lambda UVA min, and the minimum frequency value is going to be c divided by lambda UVA max. And if you calculate these values, now you just have to put in c is equal to 3.00 times 10 to the 8 meters per second as always. And if you calculate this, then you find that for UVA, you have 7.5 times 10 to the power of 14 hertz FUVA. And the maximum frequency is 9.37 times 10 to the 14 hertz. So this is the band of frequencies that correspond to UVA radiation. And now you're asked to do the same for UVB. And again, you just put in the values here, UVB. And so this is going to be less than C over lambda UVB min, and greater than C divided by lambda UVB max. And here you know that the maximum is corresponding to the same as the minimum of the UVA, so you know that it's the same value. So this is 9.37 times 10 to the 14 hertz. So that's the minimum frequencies for UVB radiation, whereas the maximum frequency works out to be 1.1 times 10 to the 15 hertz. And so this is the band of frequencies for UVB radiation.